We've seen in a previous video how we can define a trig function for any angle on a unit circle. The truth is we could have used a circle of any radius to define our trig functions. And sometimes it's more useful to think in terms of an arbitrary radius rather than a radius of 1. So here's my xy plane. Now I have a circle of radius r centered at the origin. So we go through points like r0, 0r, and so on. Well, I can still use points on my circle to define my trig functions. It's just now I have to take into account that my radius has length r. So here's my right angle, the coordinate x, y. So now the cosine of theta is again going to be the adjacent over the hypotenuse. The adjacent is my x coordinate and the hypotenuse is r. So notice for the unit circle where r is equal to 1, this just reduces to cosine of theta equal to x. So the only difference between defining my trig functions on this circle and the other circle is the length of the hypotenuse. So sine of theta is going to be the opposite over r. So y, my y coordinate over r. Tangent of theta is still y over x. That ratio is going to be the same because it's going to be a similar triangle to a unit circle. Cosecant theta, so that is the hypotenuse over the opposite. Secant theta, hypotenuse over the adjacent. And the cotangent theta, adjacent over the opposite. And again, the standard identities that we know for tangent, cosecant, secant, and cotangent still apply in this case. Okay? So we can think of our trig functions on a circle centered at the origin with any radius.